How's everyone doing? This is Josh with Heartway Farms. We're talking off-grid solar pumps and water supply solutions. We've partnered with RPS solar pumps, and we're going to be going over our complete install and how this system is going to apply to us here at the farm. So let's get into it. So we have partnered together with RPS, and they are an off-grid solutions company that helps with pumping water to farms and other areas. You can use it in your home well, you can use it for livestock, you can use it for irrigation. We specifically have a water issue here at the farm. We have a well on site that works for our residential needs as far as the home and laundry and stuff like that, but the second we go to do irrigation, large water fill-ups for like containers for the animals, we run into big problems. Yeah, we lose that water pressure very, very quickly. It just doesn't have a good recovery time on it. Those in the water world and the well world know what I'm talking about. Yeah. So we are in the process of installing an off-grid, no battery, so it's 100% solar. When the sun comes up, this system pumps the water from we have a natural spring out back that we've modified and gotten it so that we can collect the water from there. We can move it just under 3,000 feet to the front of the property through a 1-inch poly pipe, and we'll go into all of this detail with our process, but we have got the nuts and bolts of it together right now, and we're getting some of the water getting pumped up here, and we couldn't be happier. It's made a huge difference.
Yeah, there's some projects on the homestead that are wants, you know, that you want to do because, oh, this would be great to do this, and, you know, fill in the blank, it would be fun to have these animals, it'd be fun to do this. But there are some projects on the farm that are absolute needs, and that's what this was. We needed a water solution at the front of our property. You know, we qualified for the NRCS grant and got the high tunnel, which we added to the property, which was huge, and that was a huge project to accomplish, and that's all wonderful and great that we qualified for that, but watering the high tunnel is impossible currently with the water situation that we had.
And in order for the high tunnel to work, you need to have some water source.
You have to have water because it's covered, of course. And so when you take these baby steps, so when we qualified for that, we knew we needed a water solution. And we talked about all these different things between rain catchment and all of that, and we are combining a lot of these solutions, but RPS, having their pump, their solar solution out back by the spring, this is a game changer for our farm. This is something that literally is going to make our garden space, our high tunnel space, our animal water solutions.
Pasture irrigation eventually.
Pasture irrigation. These things are going to become a reality because of this solar pump being installed and having that water pumped up to the front of our property and having gravity feed coming back right now. Hopefully upgrading that in the future. So this is like seriously something that is a miracle for our farm. And this is going to be something that gives us just so many solutions to so many problems that we have had here.
And the awesome thing about it is it's not a cheap system.
No.
It is very well built. It is very the word hardy comes to mind. It's the way that they've gone into a self-install process it's been great. It's been I don't want to say flawless because you have Josh involved, which is there's always changes with that, but it's been easy to follow. It's been relatively easy to install, and we've had our own little solutions that we've had to overcome. But we're going to go into some of the other things that we're going to go into is catchment systems. So the actual container that we're pumping the water up into, it's about $1 to $1.50 per gallon to buy a 2,500 or a 5,000 gallon holding tank. We had the huge blessing of one of our other farm friends that we got for $12.50 for a roughly 300-gallon container, the IBC totes that were food grade.
Yeah.
We got those from them, and we have 7 of those set up for holding water that we're gonna show you how to, on a budget, take this RPS system, have a holding situation for your containers, and then in the future, we can always upgrade a holding tank. That's just some plumbing that we have to restructure.
Right. But this was an answer to an immediate problem.
Yes.
That in a very short amount of time, we went from not having water to the front of the property to having as much water as we need with these catchment totes.
Right.
And yeah, it just worked out wonderfully to be able to have those totes up there and just having the blessing of getting those for so inexpensive for food grade buckets.
So
totes.
for a real quick overview, at the back of our property is the spring, and our property goes from the spring, which sits at a little bit higher point, down into a creek, which is a lower point, and then it rises up to the front of our property. To the highest point is where we're going to put the catchment system. So we're pumping water. I think the actual walked out math that we got on it is about 22 to 2,800 feet that we're pumping that water. A 1-inch poly pipe that we're using, and we'll go into all the specs on that, but I think we went with the 160 PSI poly pipe, and that was because it doesn't crimp off as easy. It's a little bit, but it's not the highest dollar amount one either.
Right, because it's very expensive right now and hard to find right now.
Sourcing these things.
Correct.
So, but RPS was great. They sent out a complete package. There wasn't a bunch of extra parts that we had to run out and buy. It was a field install with a handful of tools that you take out there and install, and that it's really as far as their system goes, it's an all-in-one system as far as being complete and not leaving a lot of guesswork to the game there. So we'll go into that whole thing there, and we'll show you the whole process of how we're setting it up, installing it, and how it's fixing and solving the problems with irrigation, watering the animals, watering the garden, and just getting water on the property here.
Yep.
All right, so the deal is we have water on our property, and that's not the problem. The problem is how do we get the water to where we need the water? And all of our water is low on our property, which makes sense, and we need to get it to a higher location on our property. So a little bit of background, we live on a farm, 14 acres, and it's about 2,200 feet long by roughly 400 feet wide. So the water that we're trying to get is about 2,200 feet away from where it actually needs to be. We ended up partnering together after a lot of research with RPS solar pumps, and we have an RPS solar pump 400 series, and we're going to show you the complete install of how that's going to apply to us here, how we're going to get our water area that we have set up here on the farm, and we're going to get into that. So let's get over here and talk about this real quick. In a previous video that we put together, we have a spring that has been here on the property for decades. It's been here for a long time. And when we got here on the property, we simply developed that spring. We put a spring collection area in front of it, and we made this a spot that we then had the water flowing out of a 1.5-inch pipe. We did the math on it, and that spring flows about 3.4 million gallons of water a year, which is about 6 gallons per minute. It's very consistent. It's 48 degrees year round. And so then what we've done is we've created a budget-friendly collection system down here, and that's simply a 30-gallon rainwater collection or food grade certified barrel, and we have the water flowing into there, and then it has a discharge and overflow of a 2-inch pipe. And the idea behind that is that we can put the pump into there, and that it will produce more water than we're actually pumping at a low volume up to the top of the property. So that's how this system is going to apply to us here. And the reason we kind of went with some low budget entry level things is because as a lot of you understand, is when you're on a homestead and when you're doing farming operations, you don't always have money just to sink into a $40, $50, or $60,000 well that's 800 feet deep. You've got to come up with some creative solutions. And part of that is resourcing materials right now has been tough for us, and it's been cost effective to come up with some other solutions. So we have this catchment system here. We totally understand that this is a catchment system that we can upgrade in the future, and that's kind of why I wanted to show you this part of the step here of how we're making the system work for us, and it's going to provide for water for us now, but then it also has the versatility to upgrade that system as we can put more infrastructure into it. So that's what we're gonna get into here. All right, so we just got delivery of our RPS pump system, and we're just doing a quick package check because the UPS driver said that he wanted us to do a quick just check of the packages, make sure that there's no damage to them. They look like they're in pretty good shape. They made it all the way from California, so thanks to RPS for getting these things packaged up the right way. And we're just gonna do a quick check of the box here. And that way, when we take it out to the back of the property, we kind of know what we're looking at, number one. And number two, we have done what the UPS guy asked and verified that everything is in decent shape here. So real quick, we got a little sticker in here with a user manual. So that's laid out really nice. Thing is packaged up really securely here, so that is nice. Everything's laid out here. Looks like we got a well cap here, so a 6-inch well cap, and then some associated fittings here, and then the pump itself sits in here, and looks like the barb for the 1-inch piping that we're going to be using. We're going to be using some poly pipe and spare mechanism kit. All right, I think this is probably for the pump itself. It's got the field replaceable helical pump system, so that's probably the spare kit there. I'm making an assumption with that, but we'll dig into that further here. And it looks like we've got the controlling unit, all the electronics right here. And I'm not gonna dig into this. This has got the piping in it, and I think it's just got some associated parts and pieces in there, so that's wrapped up really well there. I'm not really concerned about that. The actual solar panels here, these boxes look like they're in really good condition, and I think that this is the aluminum bracket system for the actual solar panel mount that will go out back as well. So the only panel system I'm gonna open right now real quick is this one has a little ding on it here. So just to double check that, these are packaged really well. That's always appreciated when you have something that is of higher value being shipped to you. So, all right. So there's the solar panel. This one looks like it's in good shape. No problems there. The corners all good. It's like a protective film on it here. All right, so these panels look good. Like I said, I'm not gonna even mess with that box because it's not dinged at all. This one just had a little ding in it from shipping, which is totally understandable when it's coming from California to Illinois. So this is a total of 4 solar panels, so there's 2 in each box. This is the RPS complete system for the field install. So it comes with the pump, it comes with the mounting hardware, and then it comes with all of the initial wiring for, I believe it was 100 feet in length, which is just like their basic kind of like starter setup there. So I know that they can go upwards of, you know, if you have a deeper system, they can send out longer piping and whatnot too. So that is a nice aspect that they're willing to, man, their customer service so far has been awesome. They've been communicating great. They've been helping us size everything appropriately, as far as the pump with the output of our water source that we'll get more into. But their communication, I even called one time and hung up because I had something else I was doing, and I got a call back from them and said, hey, we noticed that we missed a call from you. Just wanted to see if there's anything we could help you out with. So they've been really responsive. You talk to real people, and that is a plus in my book. So those are all good things. So we'll continue with this project here, but this is just a quick box review of what we received. Get back. We're not letting you over here right now. Not time yet. All right, so just for frame of reference, we're at the back of the property, which is the far north of the property, and this is south facing. So we are going to be installing our panels in a south-facing direction, and they will be on a pole here. Now, once again, the pole recommendation is a 4.5-inch outside diameter galvanized post. I have looked at all of our local hardware stores, and I have talked with some of my contractor friends, and we are not able to source those right now. They have been almost impossible for us to find. So once again, for the time being, we're going to utilize a treated timber post that has an outside diameter of about 4 1/4 inches, and just about 4 1/2 to 4 1/4 inches. So it will work in this situation. We're going to mount the post in here with some concrete. We're going to have the solar panels south facing, and we have gone ahead and prepped this area. William and I and a couple of kids have been out here, and we've been clearing some of the trees and making it so it's got less interference from anything that would cause shadowing or a reduction in solar availability here at the site here. So. All right, so the spring is up here, and we have this corrugated drain tile just to help carry the water away. We're eventually going to put rock in here just to keep this dried up a little bit. And then, so this is our actual intake side, and it comes into the barrel, and then it's got the 2-inch discharge over here. And we just have this set up here to protect it a little bit. But while we were working in it. But if you look in here, we've got our intake going on over here, and we just have it curl around so it just has, the water has a way to move here. And then we've got, over here, we've got the 2-inch discharge that's constantly skimming the top and running the water away. And then any sediment's gonna sit down low. So what we're gonna do is we're gonna have a 6-inch casing that we're gonna put into here that's gonna keep the pump from stirring up anything on the bottom, and it's gonna help keep the water source cleaner and just with less debris involved with it. So we're gonna get that set up here, and then we'll get this other system installed. So we need let's say we need a 40-inch cut. But I need you to get the screw gun, and I wanna leave about this much space, and I wanna start putting holes, a bunch of holes, all the way up to like right in here. All right, we got our stuff out here with the RPS system here. We've got the pump itself. Just some key points of this thing. This is a heavy-duty pump. I had my hands on a less robust sized pump. And this thing, it feels like a real pump, my goodness. It is, just for reference, it is about 16 inches overall height there. So I guess 17 if you want a little bit of buffer space there with the nipple that has to go on there. So it's got the female threads here, and then it's got the connections here for it there. And then they have all the push butt connectors here that you can do your splicing with here. So that's the pump itself. We've got the barb connection. We're using 1-inch poly pipe for our run. It's got some of the waterproof connectors here. It's got an inline check valve on it, and then some other solar connectors here. It does have the water tank sensor on it here. That we'll get into that later here. And then we've got the actual the power system that we'll be putting on the back of the pole here that we'll be mounting up there. So that is the brains to the whole unit here that everything's going to get wired into and run up into here. So that is that box. And this is all of our aluminum channel for installing the solar panels. So this is the 4 solar panel system, top of pole adjustable mount kit. Some of the bracket system there. And then the swivel angle adjustment as well. So we'll get that set off to the side here. And then also they did send us the pressure switch. And so what we're doing is the pressure switch is going to be back here in line with the pump system down here, so that we're not trying to control the pressure switch all the way up at the destination of where our holding tank's going to be, which is, like I said, 2,200 feet away. So they have it set up so that it's I believe it was called a reverse pressure switch. So when that closes up there, it'll build pressure, it'll close the system up there on a float valve, and then the pump will sense a build in pressure and shut itself off so it stops pumping. So even if it's getting sun and it's wanting to run, it will shut it down and not let it just continue to run and overfill the tanks. This is what's going to be going inside the catchment cistern. It's a 6-inch PVC pipe. We put a cap on the bottom, and we started the holes off the bottom a little bit so that the water comes in and drains down, but that it won't disturb sediment on the bottom of the barrel. And then we've got our well cap that's going to go on top. It's going to seal it off, and everything's going to come in here. So we'll just seal this off around here. We'll screw this into place. We'll be able to drop the pump into there, and then we'll have this sealed off, sitting on top, and it will be a nice little system there. So you can kind of make this system adapt to a standard 6-inch well casing if you've got an actual well, or in our case, we had to make a cistern catchment for the spring development, and we're using the same thing here. So. All right, so this is the 4 solar panel top of pole mount adjustable kit, and it has, once again, another great instruction manual here. It gives you a quick overview about the ribs and the joints and the panels, and then the adjustable bracket area here. It gives you the tools required, equipment required, and then a little parts list there. So let's get started here. We've got our pole mount brackets here. We've prepped that with the bolts on the inside of the channel here, and then we're just holding it in place with these outside nuts here, and we're gonna mount it up here. So William, if you go to the other side there, and you put those carriage bolts through here, and we're just gonna get them all kind of relatively on there and snugged up. Yep. And then go ahead and screw your nuts on there. And the biggest thing is we're gonna double check and make sure that they're relatively, we're gonna have this facing south, because this is gonna direct which way the panels sit. And then those little lips are sitting on top of the pole at the top there, so they're holding it in place there. So that's how that whole pressure system comes into play there. So we're going to take off the nuts that we're holding this in place here, and then we're going to put this in the top one, and then this is going to be your way to slide it on the bottom one there. So that will be our pivot point for it. So we'll just temporarily finger tight this on here. Finger tighten that there, and now we can work on getting the other rail across the top here.
Oh, so it can face towards the sun if we want it.
Yeah, so we can tilt the angle of it, exactly.
And that goes right towards the sun.
So we're gonna get these facing opposite directions. So this one's gonna be facing out, and that one's gonna be facing forward, and that's just so we can get at things easier here. So we're just gonna slide these in place here. Once again, just getting everything finger tight so that we can move the channels around and get everything sized up how we want it. And everything feels like really robust. It's not flimsy at all.
Like it's, yeah.
Yeah, it's
nice metal. Feels very thick.
All right, William, take that up here. We're gonna face this one the opposite way from it. So
I'm gonna hold these up.
they're both facing. Just drop that through there. All right. Okay. So these are the solar mounting racks, and then they have the solar racks, the mounting racks, the adapter here. So you have to get these slid into place here. So all of these just kind of get pivoted to where they start to go in these channels. And so that's that one there. And then slide yours up here. And it's got the same groove system here. Just hold that there. Push it.
Sure.
All right. Push a little bit more. Oh, there you go. Okay, all right.
Yeah.
So that's just roughly there. And then we're just gonna finger tight these once again to get that rack all held in place there.
I feel there. Right there.
All right, so that's one rail together there. And then we will repeat that. So there's the channel on the back side and the front side here, and I'm just rotating those in and getting those to slide right in that channel there. So, and then about halfway, I'll just give it a quick finger tight. And then we can join the other one the same way. So it's got the outside groove and the bottom groove. And once again, we just get them to slide in the little joint right there. Then we'll just put them together and take that gap up between the two of them, snug it down. Before we put these rails on and mess with them too much here, we want to give this a quick snug down so it doesn't rotate on us and rack down on us. So we're going to grab the 9/16 wrench. We're just going to give these a little more tighten. We're going to have to come back and untighten them later on, but we're going to tighten them down so that when we're messing with these rails here, they don't rock down and whack us in the head. So we've got these balanced up on top of that mounting bracket behind me here, and we're just going to slide these bolts in here, one on that one and one on this one. And then we'll get these run down right to here. And then we'll do the same thing on the other end here. And we're just going to tip this up and rock these into the grooves here and get these things finger tightened up into here. All right. And it kind of sits, if you look at here, there's this bracket that was in between here to join these rails together, and these sit right between the other rails that were installed on there. So that makes it kind of just relatively hang right in that area. All right, so we've got the top of the pole mount installed here. We've got the other cross members and the rack system installed here. And then we've got the utility kit that they included for mounting the solar panels. So we're gonna get the panels out and we're gonna start lining the panels up along here. And then we'll be able to tilt this and get everything into place. All right, get these solar panels out. Let's pop off the packing there.
They also do a really good job at packing the
Everything.
everything in this.
Yeah. So I'll just leave this here real quick. And then we're gonna go to the back side here first, because once again this thing tips this way. So if we put this on the back side here, we should stop it from tipping down on us, right? All right, so real quick here, we've got the longer ones, and those are gonna be for these middle T-type looking ones. They're gonna go up here between the middle ones, and then you've got these zigzag L looking ones here that are the end clamps here. So those are shorter bolts that go onto there. So we're just getting this one mounted on here. It's the end clip. So these are clipped up here on the end ones. Just gotta finger tighten. And then it's got the Allen key that they sent with it. So we'll just slide that into place here. All right, about 8 inches. Once again, just snugging it down there so I can get things moved around a little bit. All right, snugging the T-pieces up here between the two. All right, this is gonna go up here. All right, well. Yeah, Jack, just a little bit.
Gonna let me go? Or let it go?
Yeah, you should be able to let it go there. And then here, just hold that for me, please. And we're gonna put the end clamps on here.
Good.
This is the strap mounting kit for the control unit that goes on the pole. We're going to take and feed this through here and here, and then it's going to go around the pole here. So that's one of the straps. And is there mounts on the back of it there, screw mounts?
Yes,
Yeah.
these here.
All right. There you go. All right, so we have our initial solar panel install done here. We've got the control unit on the back on the pole, and the other thing is just to look at, you have the fixed position tilt angle, and then you just find your line or thereabouts. So like 37 and 33 are these two lines that go through our area. We're about in the Chicagoland area. So I'm gonna make a guesstimate that if I looked on their actual system, which I think I actually can post that on here, that we're at about probably 34 to 35 degrees of angle for the fixed position. And then we're gonna range between that 11 to 50 degrees for the summer and winter angles. So, and we'll bump that up probably, so we'll probably be more around like the 14 and 52. So just kind of splitting the difference between there, because that's our zone right through there. All right, we're gonna get into our the poly pipe roll and then the other accessories that are in here. So nice thing about the RPS complete system is they pretty much include everything you need, unless, like in our case, we had the spring that we're developing, but that was just a matter of getting some of the things for that set up. All right, pull it back. Whole other box of goodies in here.
Ooh, a present. I love presents.
All right, so in here we got some grounding wire that's going to be over there for control unit panel. We got the safety line, got some clamps, 1-inch barb connection. Got our T for the top of the well connection, the well cap, which is right here. And we got our high and low water sensors.
Oh, the wire from to the box to the...
Yep, direct bury wire right there. And then the other stuff that you tape. And then this is 100 foot of 1-inch poly pipe as well. So 100 foot of pipe, 100 foot of wire, the direct bury wire, and then all the associated parts there. So we'll get into installing this stuff. All right, so for our connection here, we have the 6-inch wellhead cap that we're using to put on our pipe over there, and we're just going to get this mocked up here. So we're going to put our T running this way with the cap on it, because then we can run our poly pipe out and away to our water supply area. And having a T on the top is nice, because in the future, if you need to expand your water delivery system, you're going to go maybe to 2 different collection points. You can go ahead and have that split off a different direction. You can actually fill up like two tank systems. Like I said, the really nice thing is that they included everything that you need. So once you bring these boxes out there, all you need is a handful of tools, and you are pretty much set, barring anything specific that you need for your little operation. So, like I said, I'm just hand tightening everything on here right now. Alright, so that'll be the top, and then we'll get this all in place here, and we'll be able to run our wires through here, pass it through into our well that's going to, or our pump that's going to be down here as well. So that is that top of the cap there. So for our specific application in this, we are making this about 40 inches from the well cap to the base of the pump. And so we just went with a solid connection here with our check valve here, and then up through our connections, and then out to our barbed 1-inch discharge. So we have all solid piping through here. You can use the barbed connections that they have in the system, and you can do the barbed connection from here and then back down from here, and then have a piece of your black poly pipe for your drop. Obviously, if we were doing a much deeper system, you would use the barb, and you would have your well pump that's all the way down there, and then you would connect it into your 6-inch adapter here. So we're going to get this all taped up, and this is what we're going to see, but it's just going to be all taped up and ready to go, and then we'll get that wiring in place, and we'll get back to you here.
Here's the first piece. I'll grab this.
Alright, so we have our pipe that we installed here, we have our wire run up through the cap, and we have our low water sensor, and we're going to tape that up into this area right here. And so what this will do is, if the water draws down and it's getting overdriven by the pump, it'll shut off the pump to stop the pump from burning out. We're going to attach this to the pump. I don't think we really need it, because we have our stiff pipe here, and this is more for like if it's down 100 feet, it's your safety line for your well pump, so that you don't lose it and you have a way to retrieve it if it becomes disconnected. But we're going to just go ahead and run it through here. And once again, normally if you had this run on a poly line right here, poly line can stretch a little bit because it is plastic. So you'd want to leave, as you're taping it, you want to leave just a little bit of a loop in here so that you have some slack for your line. But because we're on stiff pipe here, I don't foresee there being much stretching. But we're just going to wrap some tape here and keep it tidy. Alright, so we got our wiring, we've got a low water sensor here, we've got the bottom of the pump right here, and then we've got the safety line in place for that there. Just put a little knot in there so it doesn't get unraveled. This is the pump wire. Just gotta get this opened up here, the outer skin of it. We're gonna get into here and expose the 3 wires. All right. And then the important thing is you've got your heat shrink wires here. And you want to put your big one over the system first. So now that's on there. And then once you strip these out, you want to put the individual ones over each wire. Then they also have number markers. And you can do one of 2 things. You can do this with your numbers, or you can take a picture with your numbers when you put them on here. So like if you want green, or red is obviously red, and then 1, and then your 2 could be your green ones, so that you can keep them organized there. So it's just important that you keep them organized. They're labeled on here 1, 2, and 3, and the reason that it is the way that it hooks up in the box is the way that they match up in here. So, and then 1 is black, just to verify. And I don't want to forget to do this here, because I almost did. So I'm going to put my heat shrink over this. And 1 is black. And then I want to get my pliers back behind you there. And I'm going to crimp this. I do not have a crimping tool with me. Alright, so now that would be 1. Kind of start in the middle and work your way out. Don't want to burn it, just want to heat it. Alright, let's wait on that one now. Blue 2 is green, and 3 is red. This would be effectively then, it's over here, it's 1, 2, and 3. Just don't want to mess it up once you drop that down. So blue is green, blue is green, I went to the little one here so it didn't get so hot so fast. Take a picture of this here so you don't forget. Then we're going to slide this one up. Feel for it to be about center. A bigger one for this. Like I said, this is a little less critical for us because it's not that but it's above water. It's not like it's down our well shaft. So it's something we have access to. So just for good measure, I'm going to complete this with a round of tape around it because it is going to be exposed. So we've got our wires hooked up here. We're just going to lay this out surface right now until we get it checked and set up how we want to. This is going to go down into here. And like I said, we're just going to strip the ends of our wires and then we'll make final adjustments. Oh, careful. So on the back here, there is the wire clip right there. So we don't want to rip that out of the way there.
Here, I'll just hold this. Here. Closer, this plug is.
Yeah. Okay. Here, let's put those down there and then make sure that we protect the chip right there. So this feeds up through here. And then once you get in there, just a little pressure on it.
How does it go through? I just put my finger here.
Yeah, it's got a rubber gasket in there. Okay. All right, and then we can strip these out here. And we're doing all this wiring before we actually hook up the solar panels to it. So if you had batteries or you had electricity or solar, you want to do that all after or before. You want to hook this up here before you hook that up to it. All right. So we have 1, 2, and 3. 1, 2, and 3 corresponds to the wires. So William, if you can grab that paper for me there and remind me, because it was so long ago. Black is 1. Green is 2, which was also blue. And then red was 3, correct? All right, give them a little tug down to make sure that they're tight. Don't want to over tighten them, but make sure they're snug. All right, now I need to look at the directions real quick to make sure we hook up these to the right area for the low water sensor. So the low water sensors go into COM1, referring to the excellent diagram here. All right, so that initial wiring is hooked up. And then we have to hook up the solar wires here. According to the user manual here, we're going to connect the RPS 400 wires together in series, is what I'm seeing here. And all that simply means is that we connect the positive and negatives, and then we have them discharge from each other. Yes. So let's do this here. We have a negative and a positive, and we're going to connect that right here. Nope, this is going to be the one end. So then we're going to have a negative to a positive. Okay. Nice, super watertight connections, which is cool. A negative to a positive. And then we have those long wires over here, Will. This one goes in, and I'm going to run this one up and over here. And then you can run that one up and over here as well.
Oh, and then the 2 ends connect here and here.
There you go. All right, so let's make sure that the unit is in the off position. There's a toggle switch right here, Marie. So we're on solar or battery right here, and we have center. So if it's in a center, it's in an off position, and then if you go forward, it's in solar. And for now, we'll plug these in. All right. And I don't know if we've got enough sun yet because we had to take a quick break.
Oh, it's lighting up.
There's a light.
Power.
All right. All right.
I don't hear anything.
Oh, now the pump is green.
All right, so we've got the pump green over on the panel. This is probably got to do, I'm guessing it's got to prime. See if we have enough sun, because we're at about 5:30 now, so I feel it kicking on. Spinning up.
How powerful is this pump? There we go.
Whoa, whoa, oh, look at that! Cool. It was just building prime and then all of a sudden it caught. Wow, that's pretty cool. All right, so now we'll have to see how this operates. And actually, we might want to get a piece of that pipe. Let's go ahead and shut it off real quick.
Where's your flathead?
I just wanted to get it so it wasn't pouring all over this right here. All right.
That's quicker.
Can you hold that up there real quick? So I'm gonna go back here real quick. Sun's going down, we might have some low power. All right, so inside here, there's a timer for the tank to have recovery on it. And then there's a how much output it's got going here.
Ah, we're like going back on and off.
Yeah, it's because the sun's going down. So we've run into a low sun phase, which is fine. This is just gonna give us a good bearing on where we're at here with this. So, but this is your output speed of your motor here. So our spring produces at about 6 gallons per minute. So we're gonna have to set this dial so that we don't over pump our spring's output and how much it will make up, and then so that the pump stays at the right level. So that's how this dial will be a timeout button for how long that pump shuts down and waits for it to fill back up again. And then this dial down here is your pump speed, which determines how many GPMs it puts out. And William is playing with the water now because Alright, so this is a 1,000-foot roll of 1 inch, 160 PSI, black poly pipe. So we've got 3,000 feet that we're trying to run to make the run from the back spring up to the holding tanks. Alright girls, you can go that way now. Woo. Get back a little further, there's asparagus right there. There's all asparagus growing right there. All right, so we ran our initial test that you saw there. We got water out of the cistern. That's a good plus. So we've got the water collecting in here, we've got our overflow work in there, and we have to get our inline pressure switch in place here. So we're gonna wire this up right to here, and then we're gonna have our poly pipe feeding off of here going up towards our holding tank. So we're gonna get this wired in place here, get this all taped up, and then we'll have this all right here at this area here that we'll be able to weather protect this area from the electronics, the pump, and just to keep this area nicer and build a little weather protection system over this area here. So that's what we're doing now. We're gonna get some Tef tape on here, get it all sealed up, because this is going to be holding pressure, because once again, this is gonna produce water, it's gonna pump it out to the holding tank, and then once that holding tank's float valve activates, which will shut, it'll stop the water from flowing up there. It'll build pressure in the line and it'll tell the system to go ahead and shut down because the tanks are full. So that's what we're at. All right, we got the pressure switch here. Pop the top off of it. We're gonna run this wire, and I'm just gonna throw a little loose knot into it here so that it doesn't accidentally get pulled back out here. So I just put a little figure 8 knot there, stop it. I'm sure you could put whatever you want to there, but just something that would stop it from getting ripped out of there completely. We're just gonna hook these up to the side right here. Alright. Make sure I'm not cross-threaded there. Nope, looking good. Nice and tight. Plastic cap here. Alright, now we can do a test maybe here. I don't know if the pressure on my hand's going to be enough, but we can always check it. So here. Alright, so I just did a quick override test on this side with turning it on and off quick. So I went to the on position and then auto, which just closed that switch real quick, or open the contact. So now it should time out for, I think for a test, we just did a quick 5-minute test set on a timer. Maybe less. So now we have to get it hooked up and see if we can't get the pressure to start working with the flow switch at the top. So because we're so far away, I just wanted to do some quick tests here. We'll start getting our poly pipe hooked up and we'll start letting the water flow through the poly pipe, and then we'll check it phase by phase as we go up that way here. So, all right, let's move on to the next thing. All right, first 1,000 feet connected. Get some water pressure built up in there, huh? Oh yeah.
It's coming.
I feel like I can hear it, like.
Well, I had it on that timer. Oh.
There we go. I was gonna say, I think I can hear it.
I'm gonna trickle. Do you need help with something?
So we had water come out of there real quick, and we're just gonna get this going to where it goes up to all of our connections. So we're at 2,000 feet of line. We've got the initial joint down there at the pump. We've got a 1,000-foot run because we got 1,000 feet coils. We got one connection here, and I think that we're about to the top where we need to be. So I think we're 2,200 feet is what we decided in a straight run, and we've got some extra for getting some stuff laid out here, and then we have the other coil to take from the holding tanks and bring it out as a distribution line. All right, moment of truth. We are going to get this line cut up here. This is at our final collection area that we're going to finally establish here. It's a good noise. Some pressure buildup in there. Oh yeah, it's pumping. I hear it. Everyone's excited, waiting for water. There it comes. Hey! Look at that. Clear spring water.
Oh my goodness, who would have thought we'd be so excited about water?
Yeah.
All right.
I need your phone.
Okay. Are you with a timer?
Yep. Just a little stopwatch on it there. I just want to see what the flow rate is on it. Because if we're pumping faster than 6 gallons per minute, we want to throttle it down intentionally.
All right, we're at 40 seconds.
Okay, so we're flowing faster.
Is that what so we need to throttle it down?
Yeah, because it's actually out pumping our cistern probably.
Well, this is going to be about 5 gallons in a minute here.
Yeah, but we want to probably cut that in half almost.
And that's to let it just be a constant flow.
Yes.
Look at how clean that beautiful spring water is. So clear and clear. It's still warm.
Oh yeah.
So we haven't even gotten to the fresh.
Well, the other thing is with it being such a hot day,
yeah,
it very well could just be heating up in that black pipe.
The black tube.
So that's why we're going to look at possibly just heating it like a trench down like a foot.
To keep it cold all the time.
Just to cool it down.
Because that'll be nice for the animals and stuff for it to be cool. Well, it's here, step 1.
Man.
Oh, you jumped on my foot.
So real quick, we are prepping our holding tanks up here. We have IBC Totes, and we are making. I'm using the top connection of it to make a fill stop valve for it that would build pressure up for the system back there at the pump. So what we're doing is I got a Hudsonville float valve that I'm going to hook up, and we're actually engineering this here. So I got the original top that comes with it. It's a 2-inch thread, and then we got a male metal thread for the inside, and then we use 2 female PVC threads on the outside. And the whole point of that is that we're making just essentially a pass-through, and then we're going to put on the top, we're going to put our barb connection that screws in. So this will be our intake from our poly line coming up from the back of the property at the spring with the RPS solar pump. And then we're going to put on the bottom, we're going to put another threaded connection that's going to have our Hudsonville float valve sticking down, and that will be the float valve that will control the height of it. So the whole tank will fill up. Once that float fill activates, it'll build pressure in the line, and it'll shut off the pump back there at the spring because it knows it's full. So let's assemble this real quick here. So I got purple primer that I put on here, and that's just to prime up these. These are already, we cranked these things down. I didn't want to belabor that part of the video for you guys. We just used some monkey wrenches to tighten those up. So I'm just going to use some glue on here, get this nice and glued up. And I do want this to be glued because this is going to be a pressure side of things here. So I do want it glued so that it can withhold some pressure here. So just push these in, push them, and then give them just a little bit of a twist and hold it. And then we're going to do the same thing on this side. Purple primer and glue. And push, twist, and then we're going to put this piece, like I said, we want to get this oriented the right way, so this is the bottom of it. So we're going to hook this up to the bottom here. It's got the pipe thread on it, and I just have a 1-inch nipple. We're going to screw that on. Just going to hand tight it real quick. I want this to be able to set up and get glued. We're going to get our caps on here so we don't lose the glue like I always do. We got a chicken that's deciding to give us some feedback back there. Someone's got an opinion. Maybe I'm doing it wrong. So we just got some monster thread tape. It's tough tape. It's just easier to use than that white stuff because that white stuff's just a little thinner and cheaper. So this is our 1-inch barb connection. Screw that onto there. And now we should have a pressure tight, watertight system that we can just screw on to the top of that IBC tote. And like I said, we can get a different size nipple if we need to for our distance there, just to depend on how deep we need to go. But we grabbed a pretty close one to let the container fill up more. And then what we're going to do is we're going to try to interconnect these containers so we can hold about 2,000 gallons of water. There we go, it's tight. So we can put that on, water can come in, The float valves can be down here, and then we can hold about 2,000 gallons of water in these IBC totes up there that we're gonna get positioned. And then those are all gonna be networked together, and we'll be able to hold 2,000 gallons of water. And I think we got a friend to give us a great deal on these. We got them for like $12.50 per tote. So huge shout out to Mo. Appreciate that. That's a big help. And we're gonna go get this installed up there. All right, so we have our 90 degree, our intake, and then our float valve right here. And it's all one system that we can just drop in so I don't lose it in the bottom of the tank. That would be a royal pain. So we're just gonna bring it in here and drop it. And then we're gonna connect this. Pushing out all the way. All right, and now we've got the water coming out the float valve. Float valve connects, shuts off here, builds pressure, shuts off the pump. So the only thing is I gotta take this off because I need to screw it on first. So now we should be able to create pressure without the hose blowing off. Let's see how that works out. We're kind of just running a rough demo on it here to get some volume here. What do you think? Fun little operation. This is huge.
It's huge.
Yeah, it's hot today. It's like 100 heat index, the fuel cell temperature.
This is going to be the first year that we don't have to be strategic about using water.
Well, and yeah, hauling buckets. I mean, the kids have been hauling buckets for how long now? 5 years.
All of us have, one way or another.
I look a sloppy mess, but my goodness, this is so rewarding. It's like just to have water there to use and not have to worry about that well not working.
First,
within 50 gallons, we're out. Our well has to stop and make itself up again.
Yeah, so we're
it's the well fine. We know we're about 175 feet deep. We stated before, but it works fine for like your residential stuff that's a couple gallons per minute.
But with the chickens and the horses and the garden, we had to stagger and take turns,
yes.
And it's been 5 years of that.
Yeah.
So this is huge. This is just huge. I mean, we could let this run all day and not blink an eye at it. It's just amazing.
So we filled up, since we did the quick install on there and just the test, we filled up 375 gallon tote of water already. That's filled. We're coming into where the sun's going down, this evening here, which is the whole point of the system, is that it, you have water sitting there to use
when you don't have solar.
When you don't have the solar. And that's what the holding tank, and then you have gravity to work for you too. So
because we have a hill like behind Josh, you can't. I mean, I don't know if you can tell via camera, but it goes up. It's a grade upward
12 to 15 feet of elevation
to the holding tanks.
So then the neat thing is we've done a full test now. That one container filled up, the float valve, it activated and it shut down. And so I went to disconnect this from it, and I could feel the pressure waiting there. And then the well kicked on or the pump kicked on and started producing from the spring out back. So it ended up being about 2,200 feet like we thought of piping and a lot of elevation, for us to go up. How neat though that you can change the speed, the variable speed nature of that pump to produce more or less depending on how much your water source is working. They put some thought in that thing. I mean, I'll give it to them. The install so far has been super easy. We've had to get creative on some of the stuff that we've been doing. Part of my desire was to get the system that would work like longer term for us. but I'm saving some money initially until we have a little bit better budget on things like holding tanks and trenching lines. So these are all above ground feeds right now, and they're just laid on top of the ground. And the cisterns or the holding tanks, like I said, we haven't gotten any like black or green, you know, 25 or 5,000 gallon tanks. Eventually I wouldn't mind saving up and doing that, but having the infrastructure that you can set it up and have it all in place and then just kind of add on to it, that's a big deal. Like,
well, and we're talking about drip lines, irrigation drip lines.
Yeah.
I mean, tons of ways to streamline just water in this area.
So I mean, you know, to give an idea, and that's something I guess we didn't talk about too much that we can talk about, is that, you know, we're using this for trees, so a small orchard. We're using it for a high tunnel. We're using it for an outdoor garden. We're using it for livestock watering, float valves. You know, we've got so many different things that we're tying into it because we have the water up there, you know, that we can have access to. So that's the end game, is to really have this be set up as a great off-grid, full-time use system.
You got a little dirty today.
Yep, sweaty. We got a lot done though. What we're doing right now is I just started it to get kind of mocked up and going here so you guys can see what we're doing. Is we have 7 tanks that are roughly 300 gallons apiece. And all 7 of these are going to be networked together so that when the pump pumps into this tank here, they all equalize and the water is risen by that. And then there's a float valve that will be inside of here hooked up to the pump that will shut off and stop running the pump when these are all filled up to max capacity. So that's what we're doing right now. Is I've got the IBC totes, we've got the quick couplings that we're putting on here, which are 2-inch quick couplings that we're using with the 2-inch thread on them, and then we're just using the black pipe. I could have done PVC pipe to network them together, but then once you glue it all together and spend the money to put all the unions and all that stuff on there, it gets kind of crazy. So using the black poly pipe, it'll take a little bit longer for it to self-equalize, but the idea is that as it's filling, it's self-equalizing anyhow, so we're not trying to do it in mass, fast volume. We just want it to self-equalize. So we're gonna network these together and get that set up. We've plumbed all of the tanks together so that they are self-equalizing when they fill. The main fill valve is coming in to here on a float valve, and then all the rest of them have shut-off valves on the bottom. So we use the 1-inch poly pipe with the fittings. They all are networked together, and we're gonna put some discharges at the ends here and down there and make like mini manifolds. That way we can tap in and run our gravity fed lines to other locations. So we're at the top of the hill, at the top of our property, like I talked about before. The spring is in the back, it sits into a valley, it pumps up to here with the RPS pump. The RPS pump fills these tanks, and then for right now we're using gravity to discharge to our property. The other thing we're gonna play with real quick later on is directly piping into a couple shutoff valves onto the RPS supply side, because it seems like that might have enough to like run some sprinklers here and there, and when these are full we can just use the sun to run a couple passive sprinklers and stuff like that. But it doesn't seem like it's going to be enough to really produce a lot of like true discharge power. So the discharge strength is going to be produced down the road with a secondary pump system. So let's show you this down here real quick. We've got the shutoff valves that are on each one of the IBC totes. We have the coupling that we have on here, and then we have it plumbed in to a 2-inch threaded, and then that comes out to our 1-inch T and then keeps going across like that. So if you come across here all the way to the end, we have just one of our quick discharges here that we have set up, and that will be part of a manifold system that we can use to
So we can attach a black pipe to that, correct, and take it over to the garden?
Yeah,
the
so we'll be
kitchen
able,
garden.
black pipes, tees, hoses,
Cool.
anything like that. So that's just running off of gravity right there. So there, if you look at the tanks here, they're all self-equalizing. This one's catching up just a little bit because it's the last one that got turned on. But if you look across the line, water does a really good job of leveling out and self-equalizing. So up here at the top, we have our main intake from the RPS pump coming in here, and we put a quick coupling so that I can take and get to the top here and service this. So I've got a little gator clip on here. They call these gator locks or C couplers. And that's under pressure. And then I can take this system. I just use one of the tops from the IVC tote, and we put the Hudson valve on the float part of it here, and we made a coupling that goes between the lid, and then this is our whip that we have set up here so that I can get it on and off and service it. And I'm trying to mess with to see how much we can get this to fill. So I don't know, this might be the max fill that we have on these. If it is, I'll have to look at maybe getting a different float valve set up, or maybe a different coupler in here. But for right now, it's working. It's got a lot of water up here anyhow. So that way I can screw this on though. And then we can just quick coupler it back onto here. And it's starting to fill again. So that was a little bit more money to have the quick coupler there, but well worth it for service and use and getting it out of here. The only thing that we might do with these is look at using some black paint and painting them black, because that will help to reduce or inhibit the growth of algae in here. The other thing that we could do is we could do like a mild bleach solution here once in a while and just dump them, because we've got the luxury of having a lot of water. You know, like I said, we're at about 3.5 million gallons of water a year, and if we just have to do a little a bleach rinse once in a while, then that's the case that we'll have to do that. So we're gonna play with it a little bit, but this is the way that we could set this up and have a large amount of water stored up here without paying a large amount of money for the holding containers. So that's it. All right, so we're gonna do a quick fill test here to see how fast we're filling up our 5-gallon bucket and a time on that, and that will give us a reference of how we're pumping to the top of the property here. So here we go. Minute 15. And like I thought it was, we're right around a minute 30 right there. 5 gallons in a minute 30. So that might not sound like a lot, but when that's running for an 8-hour cycle or a 6-hour cycle, and it's just running non-stop to fill up the tanks up top here, that is going to be plenty of water. And then as we increase our system, or as we increase our needs, we can always upgrade our holding tanks to be larger ones, 25, get a couple 2,500 gallon tanks, or maybe a 5,000 gallon tank or something like that, and we can have the water being stored up here and just running and on standby for us. So super, super excited. We got water here and it is working well.